with the Open Cloud Security Conference, and we are shifting into really deep, hands-on territory. We've talked a lot already today, and it feels like we've only just begun, about what security, open cloud security could look like, but now it's time to see how it actually works in the field. Because let's be real, cloud security misconfigurations aren't just a risk, they're one of the most exploited attack vectors out there. And at scale, it is chaos. Just ask anyone that's run a Kubernetes cluster, unless you have the right tools. And that's why our next speaker comes in. Please warm hands together for Sandeep Singh from ProjectDiscovery. If you've used tools like Nuclei, you already know the impact Sandeep and his team have had on the security community. They've helped thousands of defenders automate and scale and accelerate cloud pen testing across AWS, across multi-cloud, and always out in the open. This one's very practical. It's packed with lots of things you can take away. So please welcome Sandeep Singh to the stage. Take it away.
Thank you, Matt. Thank you for a quick introduction. And thank you everyone who is joined to watch this presentation. Good morning, evening, afternoon, based on depending on where the time zone you are. Without further ado, I will start the presentation. Let me quickly share my screen with you all. Okay. Can any of you just confirm if my screen is visible to all of you? Okay, sounds good. Okay, again, thanks everyone for joining. I will start with my presentation straight away since we don't have a lot of time. I will start with the problem statement, which is not actually not a new problem. This is something we have been known for long, where we know all the things are moving to the cloud, and over time this is just been increasing. And this is something, let's say, we always, from the security perspective, we always wanted to keep track of, not only to know about our asset, but also to ensure we are able to maintain the security controls over all the assets that are being spawned anytime in the cloud environment, and not given only the one environment. I guess over time, since the exception of, let's say, all the SaaS solution, there is always a one-click solution for all the problems you need. So it means more cloud resources are being used for all those things. So there is multi-cloud scenario where you now don't only need to just manage or look after a few of the assets or other resources that you have at one platform, but also now you need to ensure it's scattered across multi-platforms. So you wanted to have ability to quickly pull out those cloud resources across all the platforms and then manage, and then also quickly able to scan across all those things. So I mean, that's what the problem statement, or let's say the thing we are trying to present here. And I guess in this presentation, I will be talking about the tools we developed over time to actually tackle some of these problems. So there are multiple tools we developed for doing some of these things, but primarily I will be talking about few, or let's say the Nuclei and Cloudlist project, which is basically related to the problem statement we are talking about. So without waiting any further, just a quick introduction about myself. I'm Sandeep Singh, also known as Geek Boy over social platforms and bug bounty platforms. I started my InfoSec journey 10 years back I guess in 2011, so probably a little bit more than that. I started, before ProjectDiscovery, I spent my most of time doing primarily a bug bounty hunting, and also primarily on the HackerOne platform, where I also managed to be into a top 3 hacker on their global leaderboard. And I was fortunate enough to work with the HackerOne team as well on the other side, where I worked as a triage analyst for 3 years on Hackathon platform, which also helps to gain more insights about the wider problem we have that can actually solve some of the things through the automation that actually helps to do some of the work which I'm doing currently. And after that, I co-founded along with a few other co-founder friends. I started Project Discovery, and yeah, it's all. Through open source projects only. I met all other my co-founder friends through GitHub, trying some of the automation stuff, and that's how all started 5 years back. We started Project Discovery, and then we published multiple open source tools projects specifically focused on automation and reconnaissance, specifically around the offensive security. And now there are probably 25 plus open source project specifically for doing each things of in the workflow. And I mean, we are fortunate enough that all the tools that we developed and published over time got appreciated by the community members and got used a lot in a way that we currently crossed, let's say, 100K stars over GitHub, and there are, let's say, millions of users on daily basis. And there are so many contributors across globe who is contributing to these projects, specifically Nuclei project, which is Nuclei templates project, which is one of the key thing or role will play to help some of the misconfiguration detection that we looking to do at scale in the further slides. So I have listed few of the projects here, but there are so many of them. So yeah, it can be checked on the GitHub/Project Discovery as well. Yeah, before I start with this, if you have any questions throughout the presentation, feel free to drop in the chat section. I will try to pick them up by the end of presentation. Okay, so I will start with talking about the Nuclei, which is our most popular open source project, and also the key project that will actually help us to detect some of those misconfiguration we are talking about on the cloud platforms. And then I guess I will just start with the idea in terms of what we started with when we started this project. Actually, 3 days back, Nuclei project completed 5 years. And when it actually started with, the idea was pretty simple. We have lots of exploits being published on a daily basis. I mean, now it's more than what it used to before. And we wanted to have a way where we have collection of, let's say, the simple files where we actually don't need to maintain a lot of exploit scripts in different language that runs on different environment or different language. So idea was to make a simple engine that will give a user interface to write all those complex exploits in form of simple text. Like in this case, we are supporting YML template, which is simply writing a text to convert or customize any of the vulnerabilities that we might be doing at that time in let's say a PHP script or Python script or yeah, like you name it. There are always separate script for each CV is getting published at that time. So that was the idea where we wanted to focus on the making the Nuclei engine customizable enough for the user, where they don't need to learn about any let's say a programming language. We can make the engine powerful enough to make it simple to customize for user, where we just simply, as a user, we simply need to write checks for any vulnerability that are getting published. When this project was published at that time, it was only about covering the HTTP protocol, but over time this engine got improved a lot with all the active feedback or support we got from community. So starting from the HTTP protocol, now it support 8 or 9 protocols, including DNS, network, JavaScript, SSL, WHOIS, and few more. So now, yeah, the over time, the customizability factor, or let's say the support to cover all kind of vulnerabilities, not only simple HTTP based one, got improved. And I think the thing that made it more useful, or let's say successful over time, is the community contribution for the nuclear template project. So there is currently over 10,000 nuclear templates have created, and majority of them are contributed from the community itself, that actually covers all the, let's say, the latest CVs, or the CVs that have been published in the past. So there's 3,000 plus CVs, mostly covering the latest one, but yeah, it covers all the time going back, the old exploits as well. But the idea is it is simple enough for anyone to write or convert those exploits in form of template, that now you don't need to remember or manage anytime again in future. Now every time you get your assets that you are interested to scan or find vulnerabilities for, you just have list of templates that you are running nuclear against all the time. So that was the key idea to start with, to save our time, to not reusing the same exploit, or finding the exploit the next time you are testing the same vulnerability. That's how it got started. But I guess over time it got spread enough to cover various things. And the cloud misconfiguration is one of the thing that we let's say added support for it. And not only, and there is more than 400 nuclei templates just for detecting the cloud misconfiguration as well. I guess, yeah, there's few platforms that we listed, but it's something, let's say, we are adding more and more to cover all the multi-cloud platform support for it. So it's a simple vulnerability scanning, mostly powered by the community backing, where we get a lot of, let's say, yeah, exploits covered in the form of template as soon as they get dropped on the internet. Since the entry barrier is very low to write new template, it's just easier for anyone to write their customizable check for anything that they are looking for. I will start to the next thing. I mean, yeah, talking about the cloud misconfiguration, I mean, yeah, there are 100 of ways where an attacker can get into to get hold of data or information that is critical to the organization. I mean, just to recap, I guess the last month where we had the DeepSeek incident where a simple misconfiguration about just keeping their ClickHouse database instance accessible publicly, as well as having a unauthenticated version of it. So simply scanning those assets through Nuclei will result into finding that vulnerability itself. That's how simple it is to detect those. And also in terms of impact, it just leaking all the information that have the users data that have stored on that database. So yeah, just trying to share an example in terms of how a single misconfiguration can lead into all the business impact. So there are so many things that as a defender we need to think, or ensure that we are trying to uh, cover, or let's say making sure there is no way to get for attacker to get into. And for attacker, it's just the one misconfiguration that lets that lets the attacker in to get hold of all your data. And I guess that's why the important factor is that the customization is the important factor here. I mean, over time there will be, let's say, there will be many projects which have the set of templates or checks that will try to cover all the things that are known to at that point. But I think every day there is a new product or new feature or new platform are being released where it's really important to quickly cover those configurations or the access role and all the things that we wanted to not get exposed on the user side. So we really need a way to quickly convert those checks in form of templates, so we are not spending a lot of time to convert, write checks for those new features that are being released. So having something in form of Nuclei template that let you write any checks you wanted to, customizable checks as those features are get published. It's much easier to follow or keep track of all those new upcoming changes. I think the customization part is what make it, let's say, more practical, where writing new checks are just simple enough to just knowing what's being released and what we wanted to ensure not being published, and then just adding a writing a template will cover those things are checked every time you run Nuclei against those resources. Uh, yep. Okay. I mean, this is how it looks like at the end. It's just simple enough running a single nuclei command that will run through all the resources that you have. In this case, since we are running the cloud misconfiguration check, we have already created, let's say, a profile for each cloud platform, so it's easier to run or load templates for that particular platform or the platform you're testing for. I mean, there are other ways to run those checks, but yeah, the profile is basically just a simple way to load all the templates that are, let's say, being available or written for the cloud, AWS cloud configuration review. So in this case, you see simply loading profile for AWS cloud config will load the 138 nuclei templates that are written for all the services that we have on cloud, and all the permission or the things that we want to ensure. It will simply go through all the resources and output the things. I mean, the writing template is very simple enough and something I will walk through in the next slide, but and I will try to run some live demo as well if it's possible. But yeah, I mean, yeah, this is how it looks like at the end. A simple enough to run command and get through all the misconfiguration that you might have in your environment. And talking about template itself, like say how it looks like. I mean, there are multiple, let's say there are multiple templates for multiple protocols depending on what exploit or vulnerability you are trying to cover for. So in this case, we are looking at the cloud misconfiguration template, where you can say it is the first block is basically just including the information about the template itself, but the real command you can see here is actually the existing CLI of the Azure platform, where I mean here we simply use the idea of, listen, not inventing something new, where we already have a CLI utility for all the platform already available, which split out those information that you are interested in here. So simply running easy monitor and log analytics for workspace list query will simply list out all the law list of that resource, and we are basically storing that list of law listing and then iterating through all them to check for if they have public network access enabled or not. And in the matcher section, you will simply say if it's enabled, we simply write the result, or write and also include the extractor mentioning about these particular IDs have public network access enabled. So in this template, the key part is just running that already available, the CLI tool coming from all those cloud platforms, and then simply look or match for the unexpected, let's say, behavior you think. So in terms of having that most misconfigured, for example, having something having this configuration exposed publicly is not the expected one. So checking for that string will simply list out all the resources that have this configuration enabled. And there are, let's say, there are pre-created templates for most of all these platforms that looks for AWS Cloud misconfiguration, Azure platform misconfiguration, then Alibaba Cloud platform as well. And there are set of templates for Kubernetes environment as well. I mean, I can quickly, and there's something for GCP platform as well. I'm just sharing this. This is something we currently have in the OpenPR, but there are more than 200 plus checks that that we are adding in the template that will simply check for misconfiguration through all the services that we have on the GCP platform, and then all the misconfiguration. Uh, so this just goes to show how simple it is to automate all the known misconfiguration we have across all the cloud platforms, and then also the ability to how easily you can write those new ones that either might not be covered with the existing checks, but something might be applicable in your scenario or in your configuration. I mean, this was a great example the last week. The one of the community member shared a blog about where he talked about how he actually wrote his custom template to detect something in the Azure platform for this particular thing. This is just an example of how easy it is to also include any of the custom check that you wanted to check for specific to your platform. Okay. Hey, let me try to, yeah, this is something I was trying to, this is, by the way, this is pre-created environment meant to have output. So yeah, just to be sure, there's no real information is being disclosed here, but this is the Nuclei where I'm just loading a profile for AWS Cloud config review, and then it's simply going through all the resources using the AWS key, secret key and access key I have already configured is available through the environment configuration. Nuclei try to read those environment variable as default, or you can provide through configuration file as well. That's the only requirement. You just configure, let's say it's not even requirement. You have your AWS CLI configured already. Nuclei should be able to read that configuration and then pull yeah, then run the template using the same configuration to pull out all those known misconfiguration as you can see here. Okay, moving back to the slide here. The Cloudlist, the second project I mentioned. So these cloud misconfiguration is about where you have resources accessible internally that also that you need to ensure that they are secure enough or not have misconfiguration, but there are misconfigurations or issues, security issues on the cloud resources that are can be accessed through externally as well. So the Cloudlist is the project that we developed specifically for the multi-cloud platform, where we try to fetch all the asset across all the platform and all the services. So we have a centralized inventory of all the cloud resources across all the platform. And just to give quick idea, I have already have opened this project where I tried to share a configuration detail where you can say it simply, as a user, we simply need to configure the configuration file, which basically having like configuring the DigitalOcean API key or AWS secret key session token. Like there is one configuration file, you configure all those configuration at once, and then just running Cloudlist will ensure pulling all the asset information across all the cloud platform at once. And once you have all the assets, the external facing assets that are fetched through Cloudlist, then you can simply use that to scan through Nuclei that have thousands of checks to look for vulnerabilities on the external facing asset. For example, here to show the example of the Cloudlist, I have configured my Cloudlist here for the GCP environment. Simply, it can be configured for all the platform, but simply running. In this case, I have also used filter service filter to only fetch resource from the S3. But yeah, you can configure or let's say apply filter for providers or services or anything that would be it. But in the ideal world, you will configure all the platforms and it will simply fetch all the assets, IPs, DNS names through all the cloud platform at once and give you one simple file that now you can further use to pipe or scan with Nuclei itself that have more than thousand checks specifically looking for the security misconfigurations on those external facing assets. Those projects are also available and listed open source. I think yeah, I would just recommend to take a look. It is simple enough to run, but yeah, this is the example of the Cloudlist running that I tried to share to run in my local CLI as well. But yeah, these are the random generated values to ensure I'm not leaking any of the internal stuff here. But that's how simple it is enough to pull multi-cloud asset that you need to further have a centralized asset, and then that will be simply used to perform the further vulnerability scanning. But having all those assets to be fetched at one place is the real, let's say, the value or the challenge it would be without, let's say, that what we are trying to solve with the cloud list. Uh, there are some resources I have listed there that if you're interested to learn more about, let's say, writing your own Nuclei templates for any of those misconfiguration or any misconfiguration that are already not being covered in the Nuclei template project, it's very simple to write new template, like just going through the docs project on the template project will give you some starter points to let's say what things you need to ensure before you create new template. And those projects are yeah, the Nuclei, Cloudlist, and all other projects are available on the GitHub that you can simply install and ready to use. Yeah, I guess that was mostly the information I had to share. I think yeah, that might really help for a lot of folks. They're looking to automate the external, internal cloud mesh configuration at scale. I will check if there is any questions. I'm not sure if I'm able to see the chat section here. Okay. Thank you, Tony. So looks like no questions, which is good. But yeah, if there is no question, probably. Okay, I see a few raise hands. I'm not sure what it means, but let's see. Hi, Balvinder. Not sure if Lizzie wanted to speak or share something, but I just added you. Balvinder, you can unmute yourself and let me know if you have any questions on it. Your audio,
Can you hear me?
I can, but this is really not clear.
Yeah, I'll try to fix it.
If you don't
Yeah,
mind, please,
no,
that
I don't have a question. Thank you.
Thank you. I'm not sure what was the exactly question, but probably if you have something, you can drop in the comment. But I guess, yeah, I really appreciate you all attending and watching the presentation. I'm also available offline on LinkedIn, Twitter, Discord as well. If you have any follow-up question, I'm happy to answer there as well. Thank you. With that, I will stop sharing my screen and stop the presentation.